Hey guys, so today we're doing the last lesson of chapter 2. It's on two variable inequalities. So we're kind of putting the capstone on the whole chapter. We're going to kind of put it all together with absolute values and also graphing inequalities on a coordinate grid instead of on a number line. So for our objectives, we're going to be answering the question, how do we graph linear inequalities on a coordinate plane? So we're going to graph two variable inequalities and compare and contrast graphing inequalities on a number line with graphing two variable inequalities on a coordinate plane. So for our vocabulary, a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. The line is a boundary of the graph, and the boundary separates the coordinate plane into two half planes. So we're going to have half that's going to be shaded and half that's not, or a portion. So to determine which half of the plane to shade, you would pick a test point that's not on the boundary on one side of the line or the other, and check it and see if it works. If it works, you shade that side of the graph. If it doesn't work, you shade the other side. And then once you get familiar with these, you'll be able to do them without using test points. So we're going to graph a linear inequality. So in order to do that, first we have to just make a graph of the line, just like we would regularly. And then if it's a less than or greater than, we're going to make it a dashed line to say that the points on that line are not included. But if it's less than or equal to or greater than or equal to, we make it a solid line. And then we're going to pick a test point, and then if that test point is true, we shade that area. If the test point is not true, we shade the other area. So let's go ahead and graph this. Y is greater than 3x minus 1. So y is greater than 3x minus 1. Okay, if I were to just go ahead and graph this on a number line, where would I start? Well, I would start at the point -1, that's our y-intercept. And then what would I do? Well, this 3 is our slope, or imagine it's 3 over 1. So we go up 3 over 1. Now when I make this line, am I going to make this a dotted line or a solid line? Because this is a greater than, we're going to make it a dotted line, like this, or a dashed line. So make it like a line. And then we just have to pick a point that's not on the line somewhere. So, for example, I'm going to pick the point 2, 0 right here. So if I pick the point 2, 0, I'm going to substitute 2 in for x and 0 in for y. So I have 0 is greater than 3 times 2 minus 1. What's 3 times 2? 6 minus 1, and 6 minus 1 is 5. Is 0 greater than 5? No, it's not. So I'm going to pick a point on the other side just to show you that it's true. How about we just do -2, 0. So if I did -2, 0, then 0 is greater than 3 times -2 minus 1. 3 times -2 is -6, and -6 minus 1 is -7. 0 is greater than -7, so that means we would shade all of this side of our graph. So our inequality is saying it's all of these values that are greater than our equation. So let's go ahead and do just one of these. Since we already did a greater than, let's assume this one is less than or equal to. I'm just going to do it right here with you. Okay, first we're going to graph +1. That's a point. Our slope is -2 over 1, so down 2 over 1. Is it a solid line or a dotted line? Well, because I included that this isn't equal to, we're going to make this a solid line. Now we have to pick a point that's not on the graph. I'm going to do something easy like 0, 0. So 0 is less than -2 times 0 plus 1. 0 is less than 1. Is that true? It is true. So that means we would shade the side of the graph that 0, 0 is on. And that would be your solution. This is just an example. If you want to work through this, you can. I'll go ahead and put the stuff up here if you want to read through it. I just want to kind of give you an idea of what you're supposed to be doing. So graphing an absolute value inequality. So this is just like what we've been doing with section 7, except we're adding the absolute value part when we graph. So when we graph this one, Remember, absolute values are always y equals. So we need to first get that y by itself. So we're going to subtract 1 from both sides. Now, this 1 cannot be put inside this absolute value because this absolute value is all 1 unit. So we're going to write it on the outside. So negative y is less than absolute value of x plus 2 minus 1. Now, we want positive y, so we're going to take and multiply everything times negative 1. And do you remember when we changed the signs? We changed all the signs. So now y is greater than the negative absolute value of x plus 2 plus 1. Now we're going to go ahead and graph this on a number line. I may have to add more points here. Okay, so we know that because it's a plus 1, we're going to go up 1. And we know because of this plus 2, we're going to go left 2. So here's our vertex. And is our absolute value going to open up, or is it going to open down? Well, because of this negative, it's going to open down. And then what's our slope? Our a. A is negative 1, so that means we're going to go down 1 over 1 from each point. And then is this going to be a solid line or a dotted line? I know this is a lot to think of. Because it's a greater than, it would be a dotted line. Okay, so now all we have to do is pick a point that's not on that line. So I'm going to make it easy on myself, and I'm again going to pick 0, 0. So 0 is greater than the negative absolute value of 0 plus 2 plus 1. 0 plus 2 is 2, absolute value of 2 is 2, make that negative, so 0 is greater than negative 2 plus 1, and negative 2 plus 1 is negative 1. So 0 is greater than negative 1, so not only am I going to shade over here, I'm also going to shade over here. So it's everything that's on this side of the absolute value. And there you go, there's all the steps. Okay, so write an equation based on the graphs. So what inequality represents this graph? So first, what do we need to find? Okay, we need to find our vertex, which is right here. What is that point? Well, our vertex, our HK, is at the point 3, negative 2. Okay, and then we need to figure out the slope. So we need to find our A. So A is the slope of the line from our vertex going to the right. Our slope is 1, it's positive. Okay, and then we have a dashed line, so we're going to have either greater than or less than. So for now, I'm just going to write in y equals, our A is 1, absolute value of x minus 3 minus 2. Because we go right 3, we go down 2. Now, in order to figure out what this equal sign should be, let's pick our test point. 0, 0. And I'm going to plug that in and determine if it's greater than or less than. So 0 is what? I don't know what that is. Absolute value of x minus 3 minus 2. Oops, I made x 0. So 0 minus 3 is negative 3. Absolute value of negative 3 is, trying to write this to where you're going to understand. So absolute value of negative 3 is 3. 3 minus 2 is 1. How is 0 related to 1? 0 is less than 1, correct? Yes. So we're going to change this to a less than sign. It's not less than or equal to because of the dashed. Okay, I want you to go ahead and try and write an equation for that one on the bottom there. So you should have gotten this for your HK and for your A. So we're going to go ahead and put it into the equation. So y, I have negative 1/2 absolute value of x plus 4 plus 3. Now is it greater than or is it less than? It should be greater than. Okay, so here's your lesson check. Go ahead and do this problem and then answer that question. Your homework is to do lesson 2A and also the practice test. You have a test on Monday. Have a great day.